Jai Hind everyone. I am Deepak Narang, Assistant Professor in Electrical and Electronics Department of Ajay Kumar Garg Engineering College. The topic of my today's lecture is virtual instrumentation, and we shall be covering topics starting with very basic. What is instrument? How we will define instrument? What is virtual instrumentation? Followed by basic architecture of virtual instrumentation. How GUI, that is graphical user interface, become a heart of this virtual instrumentation. Then what is a small introduction of Labview, which is an example of virtual instrumentation. So starting with virtual definition of instrument. As we know, instrument is generally a device which is used to collect the data or analyze the data and to display information, like a small voltmeter which shows the reading. It is an instrument, but it is our hardware based instrument. Okay, but virtual instrumentation is an interdisciplinary field that combines the sensing hardware and software technologies together. So it brings all these technologies, that is sensing hardware and software, on one platform. So there are a few definitions which are existing in our literature related with virtual instrumentation. A virtual instrument is an instrument whose general function and capabilities are determined in software. And second is, virtual instrumentation is composed of some specialized subunits and some general purpose computer, some software, and a little know, that is how. So virtual instrumentation is the use of customizable software and modular measurement hardware to create user-defined measurement system called virtual instrument. That is, a customizable means we can uh, we can create or modify any instrument as per user requirement. But all this is done by using some software. So whatever we are using in virtual instrumentation is not exactly existing physically. Rather, everything is being performed virtually on some computer. So here we can say, when this computer is merged with some software and hardware, this become part of virtual instrumentation. So collectively, this is an example of virtual instrumentation where this is our hardware based CRO, and this the same function is being performed on by using some software where this simulation is done, and we are obtaining the same waveform here, but this waveform is existing virtually. We are using some software to generate the waveform, but here this is physical instrument, that is CRO. So collectively we can define our virtual instrumentation that combines mainstream commercial technologies such as C with flexible software and a wide variety of measurement and control hardware, so engineers and scientists can create user defined system that can meet their exact application needs. With virtual instrumentation, engineers and scientists reduce the development time and design higher quality products and lower their design cost. So, what is the need of, why virtual instrumentation has become so necessary? What is the need of virtual instrumentation in industry? This is necessary because, first of all, it delivers instrumentation with the rapid adaptability required for today's concept, product, and the process design, development, and delivery time. As we know, the biggest advantage is its customization. So that is, we can create any environment as per user requirement. Okay, which is not possible in our hardware based instrumentation. Once it is designed, so it has to be used in the same way. Okay, but in this, if we want to change the color, if we want to change anything, the size, icon size, whatever, we can customize that uh, design as per user requirement. And the same that only with virtual instrumentation, engineers and scientists can create the user defined instrument required to keep up the world's demand. The only way to meet these demand is to use test and control architecture that are also software based, software centric. Okay, so as of now, as we know, all the test and control algos are again generated in software form. So if we are not having any device which is not compatible with software, that would be of no use. So because virtual instrumentation use highly productive software, modular input output, and commercial platform, so it is uniquely positioned to keep pace with the required new ideas and product development rate. So what is next architecture of our virtual instrumentation? So this is basically the main block in this architecture is this processing data interface module, and all rest of modules are available in uh, other hardware based instrumentation as well, that is sensor module or sensor interface. Medical information system, this is actually not related to every virtual instrumentation, but the virtual instrumentation which is being used in hospitals, there we require some already some database where this medical information system interface is used. Other is processing module, data interface, and user interface. So first of all, sensor module, as its name suggests, everywhere in the first or prime part of any instrumentation is always a sensor. And a sensor is a device which detects the change in any physical quantity and converts that quantity into electrical signal. Okay. And that electrical signal is further processed by signal conditioning module, which perform many operations on that signal like excitation, linearization, isolation, filtration, and parallelly we convert that analog signal into digital signal to make that signal compatible with computer system. Okay, for this we use some AD converters that change that signal into its digital form, and that AD converter may be like dual slope ADC or successive approximation ADC. There are other methods as well, so we shall discuss this in detail in my next lecture. Next is processing module. Processing module is the integration of the general purpose microprocessor. Here we use microprocessors with this instrumentation. or we can say this is the core of this instrumentation, where all the programs are fed, and accordingly that uh, signal is processed and be, so broadly speaking, processing function used in virtual instrumentation may be classified as analytic processing like filtering, windowing, transforms, peak detection, and artificial. Second category may be AI based technique, artificial intelligence technique. And for this, we require some database interface, that is computerized instrumentation that allow major data to be stored for offline processing. Sometimes we require this database interface for future reference or for analyzing the process in offline mode. Next next block is presentation and control. This basically deals with the display unit. Okay, or we can say this is our last unit in VI. Okay, that an effective user interface for presentation and control of virtual instrument affects the efficiency and precision of an operator do the measurements, and that facilitates the result interpretation. What does it mean? That is, presentation has got an major role in instrumentation, because every reading, every analysis is being displayed in this unit, and this is that unit where some user is actually analyzing the results, and if that presentation is not okay, then our interpretation may be wrong. So here, what kind of interface are used? That is terminal user interface, graphical user interface, multimodal user interface, and virtual and augmented reality interface. This is very much popular these days. Okay, but we are going to discuss this GUI, that is graphical user interface. So how this virtual instrumentation is different to our traditional instrument. First of all, traditional instrument is designed by company. On the other hand, virtual instrumentation, where virtual instrument, it is user defined. We can change at any moment as per our requirement. Traditional instruments are function specific, that is like CRO. Once CRO is designed, we cannot use it for other application, but CRO is just to used to display the signals on its screen. That is only its function. Okay, but application oriented system that has got connectivities to other networks, peripherals, and application, due to which we can use virtual instrument in variety of areas. Here, this is based on totally hardware. This is only software based. This is quite expensive. This is initially it may be expensive, but later on its cost, it becomes very low cost, because we can reuse, customize again and again. This is closed and fixed functionality. This is open and no fixed functionality is there. Rather, there is its functionality is flexible. It is slow turn on technology. It is fast turn on technology. Its development and maintenance cost is high. Its software minimizes the development and maintenance cost of virtual instruments. So this we can say these are basic advantages of our virtual instruments. Now next is graphical user interface. In these days, we see our language or programming style has been changed. We rather than using textual language in industry or in instrumentation, we rather use graphical icons to do the programming. So why we have inclined towards this GUI? Actually, GUI interface enabled more intuitive and human computer interaction, making virtual instrumentation more accessible, because here interaction is, we can do interaction in intuitive way with the instrument. Secondly, simplicity of the interaction and high intuitiveness of graphical user interface operation made possible creation of user-friendly virtual instruments. It also allowed creation of many sophisticated graphical widgets such as graphs, charts, tables, gauges, and meter, which can easily be created with many user interface tools. In addition, improvement in presentation capabilities of personal computer allowed for development of various sophisticated 2D and 3D medical images technologies. Like, we can create 3D images of our brain, okay, kidney, by using this virtual instrumentation. And all this is possible because of involvement of GUI based language in VI. And very popular language in instrumentation which is GUI based is Labview. Okay, and the full form of Labview is Laboratory Virtual Instrument Engineering Workbench. This was launched in 1986. It's a graphical programming language, okay, that uses only icons instead of writing the text to create an application. Labview programs are called VI because their appearance and operation imitate physical instruments like oscilloscope, digital meters. So we can create in Labview. Okay, and one thing here, program term is not used. Rather, we say that VI, because we are imitating the physical instrumentation virtually. Labview contains a set of VIs and function for acquiring, analyzing, displaying, and storing the data. It also includes analytic functions for differential equations, optimization, curve fitting, calculus, linear algebra, statistics, and so on. This is not end, rather we can create charts, graphs, table, gauges, meter, tank, 3D control, 3D graph, picture. So whatever we can think of in instrumentation, everything we can design in Labview by using graphical programming on this platform. So how this language is different from text-based programming language? First of all, here syntax must be known. As we talk about C language, there are some syntax which we should remember, like we have to use printf, scanf. Okay, but here as such no syntax is required in this graphical programming. The execution of programming is top to bottom, but here execution of the program is from left to right. To check the error, the program has to be compiled or executed. Here errors are indicated where we wire the block. Rather than here some blocks are there which are connected through wires like this. and if some error is there, this wire will show some this broken wire. That broken wire indicates that here some error has been created. Front panel design need extra coding or need extra work, but has such here front panel is part of the programming. No separate programming is required for front panel design. Text based programming is not interactive, rather this is highly interactive and intuitive as well, because here in this programming, graphical programming, we can change color, their shape as well. This is text based programming, where programming is not conventional method. Here programming is based upon data flow programming. Here logical error finding is easy in large program. Logical error finding in large program is quite complicated. Okay, as we perform a big, we make big application on this platform, so their error finding sometimes become quite cumbersome. Work program flow is not visible, but here we can see how our data is flowing while executing the program. That is also possible in graphical based programming. Okay. Passing parameter to subroutine is difficult. Passing parameter to sub VI is very easy. So, what are basic features or advantages of our Labview? This is GUI based, easy to use and learn. It has drag and drop built-in function. We need not to write any program, rather just click the icon and drag onto its front panel or block window. It means we have created this program. It is based upon modular design and hierarchical design, multiple high-level development tools, professional development tools, multi-platform, reduces the cost and preserve investment, flexibility and scalability, connectivity and instrument control, open environment, distributed development, visualization capabilities, rapid development with express technologies, compiled language for fast execution, simple application distribution, object-oriented design and algorithm design. All these are features of our Labview software. So, there are basically two main windows in Labview. First is front panel, second is block diagram window. Okay. In front panels, the control icons are termed as inputs and indicators are termed as outputs. If we observe any software based, we generally on front panel is that panel where user interacts. Okay, and wherever user interaction is available, there we see such icons like text window, where like an ATM machine, we see enter the amount, password. Okay, so these are just indicator or control inputs. On the other hand, in block diagram that accompanies the program for front panel, how these blocks, how these icons which are available on front panel are connected with each other, how data is being flown, okay, that is defined in block diagram. For example, if we are simply saying enter first number, enter second number, and here this is where we are getting output. So this is our first front panel design, but in block window we have to define this is first number which is connected to some operator like say addition, subtraction, division, and its output is connected to this output indicator, and this wiring has to be done in block diagram. So block diagram window is generally remain hidden to user. Okay, and only the front panel, it is available for user every time. So user interact with front panel only when the program is running. User can control the program, change the inputs and see data update in real time. Controls are used for inputs such as slide control to set an alarm value, turning a switch on or off, stop the program. All these are available on front panel. And like I said, indicators are used as an output, like we generally use indicator like small LED. Okay, so display of some result. Okay, where output is shown. So it may be like thermometer, lights, other indicates display output value from the program. This may include data, program state and other information as well. So every front panel has control and indicator which has a corresponding terminal on the block diagram. So whatever icon we are using on front panel, it has gone some its respective terminal on the block diagram. When Vi is running, the values from control flow through the block diagram where they are used in the function on the diagram. The results are passed on other function or indicator through wires. What does it mean? If we have specified some values on control unit in front window, front panel, value 1, value 2, these values are passed to their terminal block in block panel respectively. Okay, and this and on this data processing is done, whatever operator we have applied like addition, and through wires this data that is result of that addition is passed to indicator. So this is an example of front panel. This is how it looks like on Labview platform. This is a platform of displaying temperature on this graph where, see, this is a control unit that is power on and off. Okay, here this is a legend of graph, that is we can define the, we can give the labeling to this graph. This is our scale legend. We can define the scale units for which we are using the graph, like here we are using temperature versus time versus temperature. Okay, so we are defining here time and temperature. On the other hand, the block diagram, every control and indicator on front panel has a corresponding terminal on the block diagram. It contains terminals, nodes and wires. Wire connect each of the node on the block diagram, including control and indicator, terminal, functions and structure. So whatever is available on front panel, everything is joined together by using wires. So this is block, example of block diagram. How does it look like on Labview? This is block diagram of that displaying temperature. This is front, this is its block window. So here these are wires. Okay, which are connecting all the terminals, all the blocks together. Okay. Now next is what types of wire are used in this block diagram. There are basically 4 types of wire which indicates different type of data type. Like for floating number, orange color wire is used, but again we have to see that data which are coming is a scalar quantity, 1D array or 2D array. So accordingly the shape of this orange color or wire changes. Okay. For integer number, this is blue color. For boolean means we are having some binary information, either 0 or 1, we have this green. And for string, where we are passing some textual information, we have this pinkish color wire. Like we can see here, we are not having the same color wire, rather we are using different color wire. This is orange color, that is here some scalar quantity, scalar information is there. Its color is green, that is here some boolean data is there. Okay. So this is for here, it means some integer value is there. Okay. So beside this front panel, we are having some tool palette. This tool palette is available on the front panel, which look like this. Okay. So this hand indicates operating tool, this indicates scrolling tools, this red point indicates breakpoint. Okay. This indicates color the copy the color. This is our wiring tool. Okay. So all these tools are available on front panel. Just right click on front panel or go to tool palette, we will get this. And this is control panel. This is also available on front panel. It contains all the blocks which are used on front panel. Like here we can say, which can be used for pressure measurement, like progress bar, grade bar, progress bar, grade bar, thermometer, tank, gauges. Okay. Like for level indicator, we want have such indicator which shows the level of tank. So we'll pick this one, tank indicator. And likewise, this function palette, this is available on the block diagram. So the blocks which have been used on front panel, how they are connected or whatever operations are being performed on the data which are coming through the front panel, that functionalities or that all operations like arithmetic operations or whatever like DAC operations, which that all are available in this function palette. Like here we can see this numeric function palette. Here this addition, subtraction, multiplication, division. Okay, all these functions, whatever function we can think of in our mathematics, okay, all are available in this function palette. So this is an example of very small VI problem of addition and subtraction. So we have used numeric control two numeric control blocks on front panel because we can change the value. Okay, this would be available on the front window and their result, like we have used this label as well. Its result will be shown in these two respective, and these are not numeric control, rather these are numeric indicator. So they are acting as output block. This is indicated as input block. Okay, so on front panel only these 4 blocks are available, but how these 4 blocks are connected to each other, that will be shown in or used in this block diagram window. So this is numeric block, this is block for numeric control A for B. Okay, now we are using A plus B, A minus B. So we have to go function palette and we have to drag these two icons which are for addition and subtraction, and this add block will have two inputs which are coming from A and B. So we have wired them using A and B. And likewise, we are having this subtraction block. Again, this is wired with these two blocks, and their output is given to the block of this numeric indicator. Okay, so now this is how a VI is created. Okay, now when user enters some value, say 4 and 5, this 4 and 5 are passed to this window, and this data passes through this wire to this block, and here we get this generates the result 9 and this generates the result -1, and this is information is passed back to here, and user just checks the result like this. Okay. So this was all about my today's talk, that how virtual instrumentation is replacing our traditional hardware based instrumentation, what are its basic advantages, how Labview is being a small introduction of Labview, what are its basic two windows, that is its front window, block diagram, how we can create small VI using Labview software. So this is very famous book for this Labview. Okay, thank you. Jai Hind.